and when our sun will die. It's going to be epic. Scientists explain, and they figured it out, they said. What will our sun look like after it dies? Scientists have made predictions about what the end will look like for our solar system, and especially us. We're only the third planet from our sun, and when that will happen. And humans won't be around to see the final act. Previously, astronomers thought it would turn into a planetary nebula, that is, a luminous bubble of gas and dust, until evidence suggests that it would have to be a fair bit more massive. An international team of astronomers flipped it around again in 2018, and they found that a planetary nebula is indeed the most likely solar corpse. The sun is, from what they estimate now, about 4.6 billion years old, gauged on the age of other objects in our solar system that formed around the same time, and based on observations of other stars, astronomers predict it will reach the end of its life in about another 10 billion years. There are other things that will happen along the way, of course. In about 5 billion years, the sun is due to turn into a red giant. The core of the star will shrink, but its outer layers will expand up to the orbit of Mars, engulfing our planet in the process, if it's even still here. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. One thing is certain, they said, by that time we won't be around. That's what they hypothesize. In fact, humanity only has about 1 billion years left unless we find a way off this rock, is what they, again, hypothesize. That's because the sun is increasing in brightness by about 10% every billion years. It doesn't sound like much, but that increase in brightness will end life on Earth. Our oceans will evaporate, and the surface will become too hot for water to form. We'll be about as kaput as you can get. That's what they say. It's what comes after the red giant that has proven difficult to pin down. Several previous studies have found that in order for a bright planetary nebula to form, the inner star needs to have been up to twice as massive as our sun. However, in the 2018 study, where they used computer modeling to determine that, like 90% of the other stars, our sun is mostly likely to shrink down from a red giant to become a white dwarf and then end its planetary nebula. The scientist said, astrophysicist Albert Zylstra from University of Manchester, UK, one of the authors of the paper, said, when a star dies, it ejects a mass of gas and dust known as its envelope into space. The envelope can be as much as half of the star's mass. This reveals the star's core, which by this point in the star's life is running out of fuel, eventually turning off and before finally dying, he says. He says it's only then that the hot core makes the ejective envelope shine brightly for around 10,000 years, a brief period in astronomy. And this is what makes the planetary nebula visible. Some are so bright that they can be seen from extremely large distances, measuring tens of millions of light years, where the star itself would have been much too faint to see. The data model that the team created actually predicts the life cycle of different kinds of stars to figure out the brightness of the planetary nebula associated with different star masses. Planetary nebulae are relatively common throughout the observable universe, and one famous one includes the Helix Nebula, the Cat Eye Nebula, the Ring Nebula, and the Bubble Nebula. They're named planetary nebula not because they actually have anything to do with planets, but because when the first ones were discovered by William Herschel in the late 18th century, they were similar in appearance to planets through the telescope of the time. And almost 30 years ago, astronomers noticed something peculiar. The brightness planetary nebula in other galaxies all have about the same level of brightness. This means that theoretically, at least, By looking at the planetary nebulae in other galaxies, astronomers can calculate how far away they are. The data showed that this was correct, but the models contradicted it, which have been vexing scientists ever since the discovery was made. Zylstra said, old, low-mass stars should make much fainter planetary nebula than the young, more massive stars. This has become a source of conflict for the past 25 years. The data said you could get bright planetary nebula from low-mass stars like the Sun. The model said that this was not possible. Anything less than about twice the mass of our Sun would give a planetary nebula too faint to see. The 2018 models solved this problem, showing the Sun is about the lower limit of mass for a star that can produce a visible nebula. Even a star with a mass less than 1.1 times that of the Sun would not produce a visible nebula. Bigger stars, up to 3 times more massive than our Sun, on the other hand, will produce the brightest nebulae. For all the other stars in between, the predicted brightness is very close to what has been observed. Zylstra said, this is a nice result. Not only do we now have a way to measure the presence of stars of ages of few billion years in distant galaxies, which is a range that is remarkably difficult to measure, we even have found out what the Sun will do when it dies. This was published in the journal Nature Astronomy, first published in May 2018. This is on Science Alert by Michael Starr. Please leave your comments and thank you for your support.